Hello students, welcome to Narak PU College online classes. So this is P block elements competitive test solutions. So today we are going to discuss solutions of P block elements. Okay. See the now question number 31. Question number 31. Clear? See what the question. The species says having bond angle of 120 degree is 120 degree is. Clear? You already know. To get the means to show the 120 degree bond angle, the shape of the molecule should be trigonal planar. If it is trigonal planar, then the bond angle will be what it is here. Bond angle is 120 degrees. Okay? Means what we have to identify here, you have to see the structure of the molecule. What is the shape of the molecule? If you know the shape of the molecule, then we can easily identify which compound having bond angle 120. Clear? No? If you see this, first one PH3. PH3 means you already know ammonia. Ammonia, what is the shape? We have already discussed pyramidal shape. PH3 also which shape? Pyramidal shape. And ClF3. Clear? No? ClF3. What is the ClF3 shape here? Clear? See now, and ClF3. First of all, to know the shape, you must know first of all what is how many bond pairs are there, how many lone pairs are there. That means hybridization you must know. And what is the central atom here? Chlorine. Chlorine means right here. Chlorine belongs to which group? 17th group, or we can simply say 7th group. 7th group means how many electrons we have to write here? Right, 7 electrons. Clear? So chlorine has to form how many bonds here? 3 bonds with the fluorine means it has to use 3 electrons. Next, how many lone pairs are there here? 3 bond pairs are there and 2 lone pairs are there. Clear? 3 bond pairs and 2 lone pairs. What is the shape of molecule? The molecule shape is seesaw shape. Clear? Or you can simply say trigonal bipyramidal shape also. Clear? So it bond angle won't show here. 120. NCl3 means what it is? Like NH3 pyramidal shape. Pyramidal shape, so that's why it won't also show the 120 degrees. It means BCl3. BCl3 means you see what is boron? BCl3 means boron belongs to which group? 13th group argon. We can simply say 13th group or 3rd group. 3rd group means how many electrons you have to write here? 3 electrons. Boron is having 3 valence electrons. And here chlorine, each chlorine it is form 1 bond. Means bromine means boron, it has to form 3 bonds with the 3 chlorine atoms. So it has to use how many electrons here? 3 electrons. Is there any lone pair? No. So 3 bond pairs and 0 lone pairs. What is the hybridization? sp2. sp2 means what it is the shape? Trigonal planar. When it is trigonal planar, what is the trigonal planar means what is the angle here? This is trigonal planar. Boron, chlorine, and what is one? Chlorine. This is what it is one. Trigonal planar. So what is the bond angle here? Here the bond angle is 120 degrees. So this is about what it is here. Question first. So option 4 is correct one with 32. Next question is 32. Clear? So which of the following pair of compounds is isoelectronic and isostructural? Isoelectronic and isostructural means you have to calculate number of electrons. Isoelectronic means same number of electrons. Isostructural means it should have the same structure. Clear? So I will directly do the answer and remaining you have to practice. Clear? See the option 4, option 3. What they have given here? One is IBr2 minus and another one is XeF2. What it is here? XeF2. So what it is here? IBr2 minus and XeF2. You know that first of all, isostructural. Isostructural means what should be the condition here? It should have equal number of bond pairs and lone pairs. Equal number of bond pairs and lone pairs, then automatically the molecules will have the same structures. Clear? So calculate here bond pair and lone pair. I already mentioned how to calculate trick. Here, you know that iodine. Iodine belongs to which group? 17th group, or we can simply say 7th group. And here, IBr2 minus is there. Minus means one electron gaining. Whenever it is gaining electron, one electron, it will show the minus charge. So that's why add another one electron here. Total how many electrons are there? Here, 8 electrons are there. Clear? So iodine has to form how many bonds here? 2 bonds with the 2 bromine atoms. 2 bonds means iodine has to use 2 electrons. So that is bromine and bromine. And remaining all are what it is here? Remaining all are lone pairs only. And in this case, this is bond pairs. This is sigma bonds means bond pairs. It is having 2 bond pairs. How many bond pairs? 2 bond pairs. And here how many lone pairs? 3 lone pairs. For this one also you see, xenon belongs to 18th group, or we can simply say 8th group. And here 1 fluorine and 1 fluorine. Because fluorine forms 1 bond only. So xenon has to give 1 electron, fluorine will give 1 electron and will go on the form. And here these are same here you see how many bond pairs? 2 bond pairs. And how many lone pairs? 3 lone pairs. So 2 bond pairs. This molecule also having 2 bond pairs and 3 lone pairs. And this molecule also having 2 bond pairs and 3 lone pairs. So that's why it is having same bond pairs and same lone pairs. We have the same structure. What is the structure here? Linear. I already said whenever lone pairs are greater than bond pairs, the shape of the molecule is linear. So that's why both are linear molecules only. So isostructural. Both same structure, so isostructural. Electrons you count. Electrons if you count means if you get the same number of electrons, then those species will be called as isoelectronic. You know, iodine belongs to which group? 7th group. So that's why valence electrons how many? 7. And bromine also 17th group means 7th group. Clear? So that's why how many valence electrons will be there here? Iodine valence electron 7, bromine also 7. 2 into 7 plus minus 1 means 1 electron gain. Clear? So 7 plus 2 into 7, 14 plus 1. So 8 plus 14, you will get the 22. Clear? Here also you see how many electrons are there? Xenon. Xenon belongs to 8th group or 18th group. How many valence electrons will have with the xenon? Valence electron. You know valence electrons means you know Ns2, Np6, right? What is the 18th group valence electronic configuration? Ns2, Np6 means 2 plus 6, 8 electrons. If I take halogen, Ns2, Np5, how many electrons are there? Valence electrons 7. So that's why. And fluorine and halogen, so that's why 2 into 7 plus 2 fluorine atoms are there. And 8 plus 14, total how many? 20. So that's why option 3 is the correct one. You can check for the remaining also in the same way. Next one. Coming to the 33. In which pair of ions both the species contains SS bond? Which bond here? SS bond. See, and simple thing here, by seeing this reaction, we can easily identify the answer. No need to do much time for this question. You see, no need to spend much time. Why? Because you know one option. If you see in the 4 option. Option 1, option 3 and option 4, one is common, that is S2O7 2 minus. S2O7 what it is here? 2 minus. S2O7 2 minus means you already know what is, if I write in the form of, you know, molecule, this is the ion. Molecule means what? 2 minus is there. If I add 2H plus, then what I will get? H2, S2O7. Shall I write? Just if you dissociate this, what you will get? 2H plus S2O7 2 minus. This is only. If I write in the form of molecule, why? Because we have studied in the form of molecule. If you write in the form of molecule, you will get the clarity. H2S2O7. What we will call this is oleum. What we will call this is pyrosulfuric acid. Pyrosulfuric acid, or can also be called as a what it is oleum. Can also be called as what? Oleum. So that's why. And you know pyrosulfuric acid. Pyro term is there. There will be a SOS linkage. There will be a what is here? SOS linkage. But what they are asking here? SS linkage they are asking bond. Clear? So that's why if you see in this question, option 1, option 3 and option 4 is having this ion. So that's why these 1, 3, 4 are, those are not the answers. So our answer should be which one? Option 2 is the correct. Clear, my test? That is in that way you can see. So next one. Next one, 34 if you see. So phosphoric acid and phosphonic acid. I already mentioned in the class period. Clear? Phosphoric acid. Phosphoric acid means hypophosphorus acid. H3PO2. Phosphonic acid. Phosphonic acid. Phosphonic acid means what it is here? Phosphorus acid. That is. These are the names. Clear? Hypophosphorus acid, phosphorus acid. H3PO4 means phosphoric acid. So they are asking for this one, monoprotic or diprotic. They are asking. Clear? Write the structure, then you will get the clarity and you will get the answer for this compound. So first of all, write the structure, and first of all, central atom. You have to put a double bond O and there will be a OH. So two oxygens are left. And one hydrogen I have used here. There are two hydrogens left here. I will put like this. And for this one, first of all, phosphorus, double bond O, and here what is OH. And two oxygens are used, and here two oxygens are left and two hydrogens are left. So one I will write as a OH, and remaining hydrogen I will write as a H. Clear? So here, this is a one OH is there. So that's why it is a monoprotic acid. It is what it is, monoprotic acid. But here how many OH groups are there? Two OH groups are there. It is gives H plus ion. If gives H only one H plus ion, monoprotic. It will give, this is one H plus ion, this is one H plus ion. Two H plus ions it can give diprotic acid. So option 1 is the correct one. Clear? So next one. This is monoprotic and this is a diprotic. So which of the following order is correct for the bond dissociation enthalpy of the halogens? We already discussed this one also in the PU classes. Clear? So first one, actually, fluorine, chlorine, bromine and iodine. If I take fluorine, chlorine, bromine, iodine, they have given here. Clear? So actually, what should be the order here? And the fluorine molecules are being very small and the overlapping, same orbital overlapping here. So that's why, and fluorine is a very small molecule. So that's why, and the bond between, you see this is bond. Yeah, bond is very strong. Actually, bond length is short. But if you take iodine, these are the iodine, bond length what will happen? Increasing. If bond length increasing, bond strength decreases, easily it can be breakable compared to this. Okay? But what happened? Actually, order should be this is fluorine, chlorine, bromine and iodine. Because to break this bond, you have to supply lot of energy. Clear? But in this case, fluorine, this is one fluorine and this is another fluorine. But here, and each halogen atom have, 3 lone pair of electrons. Clear? So that's why in this case repulsions will be more. Electron pair repulsions are more here. To avoid that repulsions, and these two molecules will move away from each other. So that's why what happened here, the correct order is not this, and chlorine and bromine, and here what it is now fluorine, and last one is iodine. This is the correct order. It should have highest bond dissociation energy, but and maximum lone pair repulsions in the fluorine. So that's why, and fluorine bond dissociation energy comes after the bromine. Clear? So that is your option should be option 1. Clear? 36. Question number 36. If you see here in this case, hot concentrated sulfuric acid is a moderately strong oxidizing agent. Which of the following reaction does not show oxidizing behavior? Means which one it will not show the oxidizing behavior of, what it is here, H2SO4. You know that whenever H2SO4 is act as a oxidizing agent, clear? It should undergo what is reduction. It should undergo what is reduction. Clear? So that's why if you see the first compound, Cu plus H2SO4. What they have given here? In this case, 2 moles they have taken here. CuSO4 plus what it is, man? SO2 plus 2H2O. This is the first reaction they have given. So this is act as a which one? Oxidizing agent. Oxidizing agent. Now what is the oxidation state here? Plus 6. And here sulfur oxidation state what it is? Plus 6. But here sulfur oxidation state what it is? Plus 4. When it acts as an oxidizing agent, it oxidizes copper to copper plus 2. Here 0 and plus 2. It is undergoing oxidation. And it is act as an oxidizing agent means it should undergo what it is? Reduction. So sulfur is undergoing reduction. Sulfur means here H2SO4 is undergoing reduction to SO2 means H2SO4 act as an oxidizing agent. So that's why in this case it acts as a oxidizing agent. In the same way, you see option 2, option 3, and product side SO2 is there. So in these 3 options, H2SO4 is act as a oxidizing agent only. But see the option 4. Option 4, if you see, calcium fluoride treated with H2SO4 is giving rise to CaSO4 plus what it is? 2H plus calcium oxidation state plus 2, here also plus 2. Clear? And you know this is fluorine minus 1, here also fluorine minus 1. Sulfur you see, not required all these things. Sulfur you see. Sulfur what is the oxidation state? Plus 6. And here minus 2. And calcium is plus 2. Minus 8 plus 2 minus 6 which is what? Plus 6. And here also plus 6 and here also plus 6. Is it undergoing any reduction here? It is not undergoing reduction here. So that's why. And this H2SO4 in this reaction, it does not act as a oxidizing agent. Remember? So that is how it is any compound is act as oxidizing agent means it should undergo reduction. Clear, man? So here in this case, H2SO4 is not undergoing any reduction here. To undergo reduction, what is the compound should be in the product side? Yes. So in the fourth option there is no SO2. So that is the answer. Clear, man? So next one. 37 question. Correct geometry and hybridization for XeF4. What it is, man? XeF4. I already mentioned. Trick I have already given how to do this one. And right here 8 electrons. So you already know. And xenon belongs to which group? 8th group means how many electrons we have, right? 8 electrons. And xenon should form how many bonds? 4 bonds, because 4 fluorine atoms are there. To form 4 bonds, how many electrons xenon should use? 4 electrons. So 1 electron for 1 fluorine and 4 electrons. And here how many left here? 2 lone pairs are left. These are which one? Bond pairs. So 4 bond pairs. And how many lone pairs are there? 2 lone pairs. So totally how much more here? 6. 6 means what it is? Yes, P3, D2. 3 plus 2, 5 plus 1, 6. Clear? 4 and 2 lone pairs. Then what is the shape of the molecule? Square. What is it here? Plan. So option 4 is correct. Clear? Next one. Coming to the question number 38. Clear? Question number 38. So which of the following given below is incorrect? Incorrect one you have to identify. Cl2O7 is an anhydride of perchloric acid. Perchloric acid means what? HClO4. Anhydride means what you have to do? Remove the water molecule. To remove the water molecule, how many hydrogens should be present here? 2 hydrogens. So that's why multiply this one with the 2 and remove water molecule here. So 2 hydrogens we removed. And what is left here? Cl2, 2 chlorines are left. How many oxygens are there? 8. 1 we have removed. Then 7. So Cl2O7 is a anhydride of HClO4. That is correct. O3 molecule is a bent. You already know the structure of the O2 molecule. This is what is one? Bent. And next one. ONF is isoelectronic with NO2 minus ONF. Isoelectronic with NO2 minus. Clear? Electrons you calculate. You know, oxygen. Oxygen atomic number how much? Clear? 8. And 8 electrons it will have. And nitrogen, you know, 7. 8 plus 7. Fluorine is how much? 9. Atomic number is equal to number of electrons. Clear? So that's why, or otherwise valence electrons we can take NS2, NS4. Clear? So here atomic number 8 and nitrogen 7. This is 9. 8 plus 7 how much? 15. 15 plus 19, 24. Here nitrogen, 7. 2 into 8 plus 1 because minus is there. Minus means 1 electron gain. So here 7 plus 16 plus 1. And here also what you will get? 24. Both are this one, isoelectronic. OF2 is a oxide of fluorine. So I already mentioned. OF2 it is a, oxygen fluorides. Not the oxides of fluorine. It is a, fluorides of which one? Oxygen. Fluorides of which one? Oxygen. We should not say because OF2 is there. Fluorine is more electronegative than oxygen. Fluorine gets negative charge. Oxygen gets positive charge. Negative charge is there. You have to call that one is what it is? Fluorides. So that's why oxygen fluorides. Clear? So that is option 4 is the correct one. Clear? Next one. The variation of boiling points of hydrogen halides are, they have given HF. Which question one this is? This is 39th question. Clear? So what they have given? HF is greater than, HI is greater than, HBr is greater than, HCl. This is the actually HF should get lowest boiling point. Because as the size increases, van der Waals forces increases, and automatically melting and boiling points also increases. But the HF molecule is being a very small molecule, but even though it is having high boiling point, because of what it is now? Because of hydrogen bonding. And due to this hydrogen bonding, HF molecule will have high boiling point. So option 2 is the correct. Next one. Coming to the question number 40. Coming to the question number 40 here. Strong reducing behavior of hypophosphorus acid. What is the hypophosphorus acid? H3PO2 is a hypophosphorus acid. Strong reducing agent. Yeah? So strong reducing agent means what it has to do? It has to give the, it reducing agent what it do? It reduces other substance by providing which one? Hydrogens. By providing hydrogens. So means, and here if you see the structure of this molecule, just now only we have written and OH and H and H. Clear? So means, and here H3PO2 is a powerful reducing agent. Why? Because of mainly these two hydrogens which are directly attached to the phosphorus. And these are the two hydrogens responsible for the reducing property of what it is, H3PO2. It is a reducing agent means what? Central atom, when it acts as a reducing agent. Clear? Central atom is there, and it is reducing agent means what it should do? It should undergo oxidation. Oxidation means which one we will see? You will see the oxidation type of central atom only. Clear? Means these hydrogens, this hydrogen is there. This is actually not the responsible for reducing property of H3PO2, because this hydrogen is directly not attached to the phosphorus, and these two only directly attached to the phosphorus. So that's why phosphorus it gives these two hydrogens to other substances, and other substances get reduced. Clear? So that is the main one. So sometimes they will ask H3PO3 is there and HPO2 is there. H3PO3 will be there. Which is powerful reducing agent? OH and OH and H. Which one is powerful reducing agent? You have to see here direct hydrogens which are directly attached to the phosphorus. How many are there here? 2. But here how many are there? 1. So it can give the 2 hydrogens to the other substance. So that's why other substance get easily reduced. But here how many hydrogens it can give? 1. So that's why it is a powerful reducing agent than the H3PO2. Clear? So more the number of hydrogens directly attached to the phosphorus, and that compound is act as a powerful reducing agent. Clear? So that is option. So your option should be here. So presence of they have given. Okay, for all cases they have given. So that's why you can choose the option here. Option 1. Clear? Next one. Part E1. Acidity of diprotic in aqueous solution increasing in the order. Acidic nature I already mentioned. As the size increase, all are having hydrogens, all can give the H plus ions, but which one can give the H plus ions very easily? That is a strong acid. So as the size increases, you know, and the central atom and hydrogen bond will be very weak and easily break. It can give the hydrogen H plus ions very easily. So that's why what is the option one here? And H2Te is a more acidic than the H2Se than what it is H2S, because here you see, and this is hydrogen and this is tellurium. This bond is very weak, so this bond easily breaks, and this compound gives the H plus ions very easily to the other substance. So that is a strong acid. So option 1 is the correct one. Clear? Next one, 42. Coming to the 42. Clear? XeF2 is isostructural weak. Clear? So I already mentioned isostructural means what does it mean? Both should have the same structure. To have the same structure, two compounds to have the same structure, the number of bond pairs and number of lone pairs must be equal. Clear? Find out how many bond pairs and lone pairs are there, and I already mentioned how to do this one trick. And options also you do that in the same way, and which molecule has the same number of bond pairs and lone pairs with this XeF2, and those will have the same structure. Your option should be here option 2. You just do it. Previous only I mentioned here option 2 is here. How many bond pairs you will get here? 2 bond pairs, and 3 lone pairs. Clear? XeF2 will have 2 bond pairs and 3 lone pairs. And options you see. In the option, which compound will have the 2 bond pairs and 3 lone pairs, and that compound and XeF2 will have, means both are isostructural. You can see option 2 is the correct one. You can use that. Clear one? Next one, 43. So see the 43. When chlorine react with the hot concentrated sodium hydroxide, the oxidation number of chlorine. You know, chlorine whenever reacted with NaOH, we have mentioned dilute NaOH. What is the answer, Maria? NaCl plus NaOCl plus what it is, H2. This is with dilute or cold NaOH. But whenever it is reacted with concentrated NaOH, clear or hot NaOH, I said very important this reaction is. You will get same NaCl plus NaClO3 sodium hypochlorite plus what it is, H2O. So now they are not asking this, they are asking concentrated NO3. What is the oxidation state? Elemental form, oxidation state is 0. Sodium is +1, chlorine is -1, and sodium here +1, oxygen is -2. 3 into -2, -6, and here +1, -5. Total -5 means here it should be how much? +5. So chlorine oxidation state from where to where? First of all 0 to -1, and another one is 0 to +5. So our option should be option 2 is the correct one. Clear? Next one, 44. Question number 44. Oxidation state of the phosphorus. You already know how to calculate the oxidation numbers. I need not to mention. And one I will do, you can do the remaining. And P4 H4P2O5. Clear? So hydrogen how much? +1. Oxygen is -2. That will be X. 4 into +1 +2 into X and +5 into -2 is equal to what is 0. So 4 plus 2x minus 10 is equal to 0. So 2x is equal to 6. X is equal to what is 3. So in H4P2O5 you will get option what is 3. Clear? And the next if you go H4P2O6 you will get the 4. H4 same in the same way you have to do. You do it, you know already. So I will not discuss that. So you can do, and you will get the option 4 is the correct one. You have studied this one in the first year only. So I need not to discuss all this. Clear? So next one. Clear? Coming to the question number 45. Question number 45. Which of the following oxidation states are the most characteristics for lead and tin respectively? This is actually 14 blue filaments. No problem. You know carbon, silicon, germanium, tin, and what it is lead. Clear? You know. And what is the common oxidation states for the 14th group elements? 4 only. Clear? So here plus 4 and here plus 4 plus 4 plus 4, but last one is what it is now? Plus 2. Why? Because of inert pair effect I already mentioned. Clear? So always last element will show the 2 units less oxidation state compared to the remaining. So that's why lead and tin. So what they have mentioned here, first they have mentioned lead. Lead is plus 2 and tin is how much now? Plus 4. So that's why, and option 2 is the correct one. So 46. So which of the best description of behavior of bromine in the reaction? They have mentioned reaction H2O plus Br2 is giving rise to HBr plus H2O Br. Very easy question. 0 minus 1 and here what is OH minus then Br plus 1. Clear? So what is this? And bromine is minus 1 means reduction and bromine plus 1 means what it is? Oxidation. So both the oxidation and reduction. So oxidized option 3 is your. Next one. Coming to the question number 47. Clear? So which reaction is not feasible? Feasible means not occur. That you have to identify. Clear? You know that here all they have given halogens over here. Clear? Halogens compound. Halogens reactivity, you know what is the reactivity of halogens? Fluorine is more reactive than chlorine, bromine, and what it is? Iodine. This is the reactivity of halogen. Fluorine is very reactive, and after that chlorine, bromine, and iodine. Clear? See now, you know one concept here. Always more reactive one can replace us or displaces the less reactive one from their compounds. Clear? That is one concept. Now first one, they have given 2Ki plus what it is now? Br2. What you will get here? That is 3 kBr they have mentioned. It is wrong. 2 kBr plus what it is now here? I2. So 2 kBr plus what it is? This is the equation. 2 kBr plus I2. See in this one. And here, if you will see this reaction, bromine replaces the iodine here. Instead of iodine, which one has come here? Bromine. Means bromine and iodine. Which one is more reactive? Bromine is more reactive than the iodine. So that's why more reactive one. It is a less reactive one. More reactive one can replaces the less reactive one. So this reaction takes place. Clear? In the same way, if you take the second option, 2 kBr plus I2 is giving rise to 2 Ki plus what it is now? Br. Will the reaction takes place? No. Why? Because it is a less reactive and bromine is a more reactive. Less reactive one cannot replace the more reactive one from their compounds. So this reaction will not take place. Remaining reactions it can easily take place. Clear? So option 2 is the next one, third one, chlorine and bromine. Which one is more reactive? Chlorine can easily displaces the bromine. Oxygen and fluorine. You know, fluorine is more reactive than oxygen. So that's why and reaction will take place. Clear? Oxygen will be replaced by fluorine. Clear? So that is 48 question. Coming to the question number 48. So which of the following arrangement does not truly represent the property indicated against it? Clear? So first one, oxidizing power. You know reactivity and oxidizing power is fluorine, chlorine, bromine, and what it is? Iodine. This is oxidizing power. Clear? That is correct only. Electronegativity. You know fluorine is the highest electronegativity than the chlorine, bromine, and what is iodine. This is electronegativity. This is also correct only. They have given second. Electron affinity. Electron affinity means you already know. This one will have electron affinity. Chlorine. Chlorine will have more electron affinity than the chlorine. And what is it? This is electron affinity. Correct only. Bond energy. Bond dissociation energy. What is the R of bond dissociation energy? Chlorine is greater than bromine. Is greater than chlorine. Clear? But here they have given which one they have given first. In the reverse means they have given increasing order. So increasing order means what you will get here? Fluorine should come less and bromine and what is it? This is should be the answer, but fourth one is wrong. That is the answer. So which of the following is 49? Which of the following is most acidic? Clear? So they have given N2O5, P2O5, AS2O5 and Sb2O5. You know, these are oxides of different elements. They are nitrogen oxide, phosphorus oxide, arsenic oxide and antimony oxide. So these are oxides of different elements. I already mentioned whenever oxides of different elements, then which one will have the highest electronegative, and that oxide is the more acidic. Clear? So now nitrogen, phosphorus, arsenic and antimony, which element has the more electronegative? Nitrogen. This is more electronegative, so that's why, and this is most acidic compared to here. This is the order. Because phosphorus and arsenic, phosphorus is more electronegative, so P2O5 is more acidic than the AS2O5. So that is, means option 1 is the correct one. Next one, question number 50. Clear? Repeated use of which of the following fertilizers would increase the acidity of the soil? Acidity of what is here? Soil. See, this is that I am saying ammonium sulfate. What it is here? Ammonium sulfate. This is the answer. Why means, you know, it is a salt. It is a what it is here? Salt. It is a salt of combination of weak base and strong acid. If you write this equation, how it has formed NH4OH plus H2SO4 combined. Take the 2 moles here. Clear? 2 hydrogens and 2 OH will be removed as a water plus remaining what it is there now? NH4 twice SO4. Clear? Same. If you dissolve this compound in the water, it gives the NH4OH, and because it is a salt, it undergoes dissociation and gives the base ammonium. You know, this is weak base, but it produces which one? Strong, very strong acid. What is that? Is H2 SO4. Clear? Means when you use this ammonium sulfate as a fertilizers, when you use that, and it produces weak base and strong acid. Clear? And keep on repeating use, then what will happen? Acidic nature of the soil increases. So that is, your option should be option 3. Clear? Next one. Coming to our question number 51. Oxidation. If you see remaining superphosphate of lime. Clear? Lime means, you know, calcium will come here. Calcium hydroxide is a strong base, and phosphoric acid also strong acid neutralization. Clear? So if you take potassium nitrate means what is the formula? KNO3. KNO3 if you dissolve into the water, what you will get? KOH plus HNO3. You will get, this is strong base. This is what it is, strong acid. So soil will means acidity of the soil will not increase here because both are neutralized only. But in this case, weak base and strong acid. So acidic character increases. That is clear. Next one, 51. If you see the question number 51, we have discussed this is also oxidation of thiosulfide by iodine. Thiosulfate by iodine. Iodine. What is the thiosulfate? IO we have already discussed. Na2S2O3. What is the reaction here? You will get Na2S4 O6 plus 2 moles of Na. You have to take here 2 moles. Clear? This is the reaction. This I already mentioned. Sodium tetrathionate. What is this name? Sodium tetrathionate. So what should be your answer? Thionate ion. Means that is option 1 is the. So next one is 52. 52. Which of the following oxide will be the least acidic? Clear? So they have mentioned AS4 O6 and AS4 O10, and the next one is P4 O10, and the next one is P4 O6. Simple, this is very easy question only. And you know that one is phosphorus pentoxide, phosphorus trioxide, arsenic trioxide, arsenic pentoxide. Clear? First of all, these are means they have given one is arsenic and another one is phosphorus. Which one is more acidic? Arsenic oxides and phosphorus oxides. I already said, and oxides of different elements. You have to see the electron negativity for the acidic character. Clear? So that's why phosphorus and arsenic. Which one is more acidic character? Phosphorus oxides are more acidic than the which one here? Arsenic oxides. So they are asking here which of the following is least acidic. Means these two are more acidic compared to these two. Because these are phosphorus oxides, those are arsenic oxides. Clear? Now between these two, which one is least acidic you have to see. And here arsenic, here also what is arsenic, same element oxides, and you have to see oxidation number for the acidic character. Here what is that oxidation number? Here +5, and here oxidation number is +3. So +5 means it is more acidic, it is a less acidic. So As4O6 is the least acidic among these compounds. So option 1 is the correct one. So which among the following is paramagnetic? Paramagnetic, to show it should have the at least one unpaired electron. Clear? So option is ClO2. If you see the ClO2 structure, clear? So you know that chlorine NS2, 3s2, what it is here? 3p5 means you will get there 2 electrons, and in this you have 1, 2, 3, 4 and 5. Clear? So how many electrons are there here? Only 1 electron. Only one unpaired electron is there. Only one unpaired electron means chlorine should form only one bond. But here you see it is making bond with oxygen. Clear? So means, and here chlorine you already know. So this is, if you write structure like this is oxygen, it forms how many bonds? 2 bonds. If I write like this, how many bonds chlorine is forming here? Chlorine is forming 4 bonds. So that's why. And in this case, if I write here 1d electron, clear? 1 electron will come. Clear? So that's why. In this case, what happened? ClO2, it forms 1 daily bond. Why? Because these 2 electrons are used to form one bond with the one oxygen, another bond with the another oxygen. Clear? So another one oxygen is left here. If it is making a bond with oxygen, oxygen should attach with the how many bonds here? 1 bond only, but oxygen balance is how much? 2. So that's why this electron will not be used to form a bond between the chlorine and oxygen. Okay, there should be a double bond. For forming another double bond, it is not having electron, single electron. So that's why what it will do, it will give one more pair of electrons to oxygen and make a which one? Dative bond. And here one more pair will, one unpaired will be there on the chlorine. So that's why it is having one unpaired electron. So it is a para. Next one. 54 direct question. Which of the following statement is false? Radon is obtained from the decay of radium. That is correct only. Helium is a inert gas. Xenon is most reactive among the rare gases. Correct only, because xenon only forming the compounds among the noble gases. Xenon difluoride, xenon tetrafluoride, xenon hexafluoride, XeO through all. The most abundant rare gas found in the atmosphere is helium. Wrong it is. Which one? Argon. So option 4 is wrong. The acid which has peroxy linkage. Peroxy linkage. Peroxy linkage means what is that? O bond linkage should be there in the compound. So which one that compound they are asking? Which one? Carous acid. What is the carous acid formula? Carous acid. It is a per acid. I have already discussed. Per oxo monosulfuric acid. Per oxo monosulfuric acid. We have already discussed sulfuric acid. That called as a carous acid. Sulfuric acid is, this is the sulfuric acid. peroxomonosulfuric acid. This is peroxy bond. Clear? So that compound we will call it as a corrosive acid. Direct questions these are. Next one. Coming to the question number 56. Clear? Chlorine, bleaching action of chlorine is due to which one? Due to what it is? Oxidation. Clear? Because you know, whenever chlorine in the moisture, I already said it is in the moisture only, it acts as a bleaching agent. It will gives 2 HCl plus 1 nascent oxygen. This nascent oxygen is responsible for the oxidizing properties and bleaching properties. So that's why it provides oxygens to other compounds. So it is a oxidation. So that's why option 4 is the correct one. 57. Coming to the 57, phosphonium iodide when reacted with NaOH, what will be the products here? Clear? Forms which one? Na and I, you will get NaI plus 1H and OH will be removed as a H2O. Then which one is left here? PH3. So this is the phosphine preparation of compound. Clear? Next one. 58. Whenever PCl3 is reacted with water, what is the compound they are causing? You already know that here Cl and here H will be removed as a which one? HCl plus OH will be added in place of what is chlorine. So that's why, and put here 3. Clear? 3Cl and 3H will be removed as a 3HCl and another 3 OH groups are there because H2O how we can write one? H and OH, 3 OH and 3H. So 3H plus 3Cl, 3HCl and here 3 OH is there and here instead of chlorine OH will come. This can be written as a H3. So this is our option. So next one. 59. See the question number 59. When phosphoric acid is heated to 600 degrees centigrade, the product formed is phosphoric acid H3PO4. H3 what it is here? PO4. Heat this one at what it is here? 600 degrees centigrade. Then what it is It is dehydration. Water molecule will be removed. Then what you will get here? Remove water molecule. And if I remove water molecule in this case, then what will happen? You see here. And remove water molecule, you will get the H2O. H2O, how many you will get? 3. Clear? Next, what you will get? P2 is there, and 8 oxygens are there. 3 we have used. O5. P2, O5. This is clear? Option 1. So next one. Which of the following is nitric acid anhydride? Nitric acid means you already know what is the nitric acid formula. HNO3. Anhydride. Anhydride means what you have to do? Remove the water molecule. To remove the water molecule, we need 2 hydrogens. Multiply this with the 2 and remove water molecule 2H, 1 oxygen. What left here? 2 nitrogens are left. N2. 6 oxygen. 1 oxygen we have removed. Then what do we get? O5. N2O5 is the anhydride. And this is about the solutions of your competitive P block elements.